All right, everybody. I've had some students asking me for a solution to the last problem in lesson 11.4. So I figured I'd do that here. This problem actually comes to us from an ode AIME. So if it seemed hard, yeah, it's because it is meant to be hard. This was actually number 4 out of 15 here. So we are told that we have two lines, 8y equals 15x and 10y equals 3x. So I'm going to go ahead and sketch the lines first. As always, you want to have a nice picture of what's going on here. So the first part is that you have 8y equals 15x. That converts, if you divide both sides by 8, you get y equals 15/8x. 15 over 8 is pretty close to 2, so it's a line approximately slope 2 here. I'm going to go ahead and sketch that in approximately here. This is y equals 15x over 8. Similarly, we have the second line here, 10y equals 3x. And again, divide both sides by 10, you get y equals 3/10x. So that's a line with a relatively shallow slope. So it looks something like this here. And again, not to scale, but, you know, we try. So this is y equals 3x over 10. Now, we are given that there's a point somewhere here. I'm going to call, and it's going to be 8, 6. So it's about here-ish, I would say. Here's 8, 6. And we have a point P that's on this line here, and a point Q that's on this line. So that we have a midpoint here. So that means it's going to look something like, something like this here. And again, this is not drawn to scale, but we do what we can. And we know these are the same. Now, of course, the biggest question is, how do we deal with this here? If we had coordinates for P and Q, then we could just simply use the midpoint formula and all it'd be well. Unfortunately, we don't, but, you know, there's still ways that we can get around this here. So let's look at this point Q, for instance, right? We know this point Q is on the line y equals 3x over 10. This means that the coordinates of every point on this line has to satisfy this particular equation here. So if I substitute in a value of x and substitute a value of y, if it's on this line, then it has to satisfy this relation here. So since we don't know where Q is, we don't know what the coordinates are, let's start with something here. Let's say that the x-coordinate of point Q is, say, m. Now, because we know y equals 3x over 10, if I substitute an m here, I get 3m over 10, and that's going to be the y-coordinate that's going to pop out. So you get m, 3m over 10. That's going to be important to us here. Now, for the same token, same technique here, we can do the same thing over here. Now, note I'm not going to pick m. I'm going to pick a different coordinate here because notice the x-coordinates don't match. This should not be a vertical line. Or rather, if it is a vertical line, then, you know, so much the better. But if it, you know, we're taking into account the fact that it may not be one. I'll call the x-coordinate here n. Again, we do the same technique here. We note that n is the x-coordinate here. I can substitute this in to get the y-coordinate. I get 15n over 8. And now, I've got the coordinates of these 2 points, so I can now use the midpoint formula here. So in this case here, we now have two things. So one thing that I can write here is that by equating the x-coordinates, we know that h should be the halfway between m and n, so m plus n over 2. This means that m plus n is 16. That's useful. Also, we now can use the same thing here. We should be able to say here that 6 is going to be equal to 15n over 8 plus 3m over 10 all divided by 2. Now, I'm going to simplify this a little bit, make this a little easier for us to deal with. So we see here, we can multiply both sides by 2, so you get 12 equals 15n over 8 plus 3m over 10. I'm going to multiply by 40 to get rid of all the denominators here, so I multiply both sides by 40, you get 480 equals, so we multiply this by 40 here. 40 divided by 8 is 5, so you have 5 times 15 is 75n. And then we have 10 goes into 44 times, so 4 times 3 is 12, so you have plus 12m here. So I've got two equations here, this and this. Now, you should recognize this from Algebra 1 here. This is the idea of writing a system of equations and solving a system of equations here. So, you know, you can use whatever techniques you'd like. So, for instance, you can solve for m in terms of n. I note here there's an m here and there's an m here, but this is 12 times too big. So what I'm going to do is I'm going to multiply both sides of this by 12, scale it up, and then subtract it from here. Okay, so 16 times 12. Well, that's 16 times 12, that's 14 squared minus 2. 14 squared is 196. So you get 194 equals 12m plus 12n here. And now we can just install that here. 12n plus 12m. We can subtract everything here, so the m's go away, which is what we wanted. You get 480, so that means we get 63n is 480 minus 194. Well, minus 194 is minus 200 plus 6, so you get 280 plus 6, so it's 286 here. Wait a minute. Oh, I'm sorry, I screwed up. This should be 192 here. I apologize. So I'm going to go ahead and fix this here. This is a 192 here. We can do that. We set this up here, and this should be 288 instead. I apologize, ladies and gentlemen. You know, sometimes my mental batteries are still not running properly. So you can divide both sides by n. You get n equals 288 over 63 here. Note that in this situation, both of these are divisible by 9, so I can divide both numerator and denominator by 9. The 63 divided by 9 is 7. 288, well, let's see, that's 270 plus 18, so if we divide each of those by 9, you get 30 plus 2, or 32. Okay. And I think you can just multiply this out to be sure. So now that tells us n is 32 over 7. So we could figure out what m is and then solve it that way. But note that I can try to minimize the amount of calculation by doing this here. We know that the distance from P to R is half of the distance from P to Q because R is the midpoint here. So if I can figure out what P is and use the distance formula and finish it off and just multiply by 2. So we know that 15 times 32 over 7 divided by 8 is going to be the y-coordinate point P. Okay? So in this case, that's just 15 times 32 over 7. Dividing by 8 is the same as multiplying by 1/8 here. So we can see the 32 and 8 cancel, leaving me a 4 over here in the numerator. So we get, in this case, 15 times 4 is 60. So 60 over 7 here. And therefore, the point P is going to be at the point 32 over 7, comma 60 over 7. Okay? That's the coordinates of point P. And now, we can go ahead and figure this out here. We can now calculate the length of PR. So PR here, again, we just used this distance formula here, okay? So we knew that this was 8, 6, so now we're going to go ahead and connect it. So it's going to be 8 minus 32 over 7, all squared, plus 6 minus 60 over 7, all squared, okay? Excuse me. Alrighty, so let's see. 8 is 56 over 7. 56 minus 32 gives us 24, so you get 24 over 7, all squared. Plus, well, let's see, 6 is 42 over 7. 42 minus 60, so it's going to be a negative 18, but that's okay. Okay? So we have something that looks like this here. So now we're just going to go ahead and multiply this out. Alrighty then. So this is here. Both denominators are 49, so that's actually pretty good for us. So 24 squared, let's see, 24 squared, if I remember correctly, is 576. And then 18 squared is 324. So you have that set up here. And this is the square root of something over 49 here. 576 and 324 actually very nicely add up together to make 900. And we are very happy about this because both these are perfect squares. So this is just the square root of 900 divided by the square root of 49, which is just 30 over 7. Quite nice here. So now we know, therefore, that PQ is just double PR, which is 2 times 30 over 7, which is 60 over 7. And note that 60 over 7 have no common factors other than 1 here. The problem asks, made sure that the fraction had no common factors other than 1. So that means you just add 60 plus 7, and yet yields us the answer of 67.